Welcome everyone to this new video tutorial. We're going to see right now shape detection in a live video. So for example, I have a few objects like this one. We want to detect the shape of this object. For example, this one is a rectangle. Or this second object, a circle. This object kind of rectangle, but not exactly. We're going to do this in 3 simple steps. First one, we need to detect the object removing the background. So we will have a mask. Second one, when we have the mask, we find the contours. Finally, third one, from the contours, we're going to detect the shapes. Just as that, let's start and let's see. First, we start detecting the object, so we remove the background. We import CV2, we import numpy as np. Let's load the video from the camera. Cap is equal to cv2.video capture 1. 1 is my second webcam. If you have only one webcam, you need to use 0. 0 for the first, 1 for the second, and so on for the other webcams. While true, now we load the frame from the webcam. Underscore frame is equal to cap.read. Let's show the frame. cv2.im show frame and then frame. Wait key event key is equal to cv2.wait key 1. So if we press any key, if key is equals to 27, which is the S key on the keyboard, we break the loop. So it means we want to stop the video. Once we break the loop, we release the camera cap.release and finally cv2.destroy all windows. Let's run the script. If everything is correct, we get the video from our webcam and we get it, so it's fine. First step. As you notice, I took objects with only red color. To find the mask, there are different methods. We're going to use the HSV color space. If you don't know what is this, you can check on my other video tutorial. So it's about detection based on the color of the object. We're going to apply that method right now. So let's stop this one. We can press ESC on the keyboard and we will stop the video. Let's apply the HSV color space. So as it is HSV, we need to convert the frame, which is BGR color format, so it stands for 3 channels, blue, green and red, in HSV. HSV is equals to cv2.cvt color. We convert the frame to cv2.color underscore BGR to HSV. Once we have the HSV, we need to define a range. As we cannot detect only one specific red, as we can have more red, some based on the lighting, the red can be in some part brighter, in some part darker, so we need to define the range. We have lower red and we need to create an array, np.array, and let's define now, let's put 0 0 0 for the moment. Later we will change this, and then wait a moment, upper red, which is to np.array 180, 255 and 255. And then we use this range. The mask is equals to cv2.in range of the HSV lower red and upper red. And now cv2.im show mask and then mask. Let's run the video. As you can see, nothing changes, as we need to set properly the parameters of the range. For example, the red, let's try to change the first one, minimum of 19. So it's HSV color space, and we are defining the lowest H hue, it means hue, S for saturation, and V for value. The same for here. These are the upper values, so that we can define a range. And we can find the proper one by testing it many times. Now I found properly the red, almost. We can see some detection of the red. To work properly, we should have only the red should be white in the mask, and all the rest should be black. We can adjust it trying many times, but it's better to create a track bar so it will be much faster. So let's do this way. To create a track bar, first we need to create the window. So cv2.named window, and let's call it frame, and it's the window where we're going to put all the track bars. After that, we create 6 track bars because we have 6 values that we want to change in real time. First one, cv2.create track bar, and then track bar name. Let's call it lower H, and then on the window, which is frame, and then the value of this one 0, the standard value, and the maximum value 180, and then nothing function. This function, we're going to create it here, just call it def equals nothing x, and then pass. Short explanation of this: each time we use the track bar, we can pass some function here. So if we want to do any operation here, we can do it. As we don't need to use this function, we just put the function nothing and we just do nothing. We have the first one. Let's create 6 of them. I copy this one 5 more times. 1, 2, 3, 4, 5. As we are going to work with lower and upper HSV, the first 3 will be for the lower, so lower H, lower S, lower V, and then upper H, upper S, and upper V. And here we give all the maximum values. So the lower, it's 0, 255 the maximum, 255, 180. So this is the starting value of the function of the track bar. As here is the maximum, we put all to the maximum, 255 and 255, and it should be okay. And now we let's run the script and let's see if we have the window with the track bar. And I did some mistake. I put the track bar on the frame, and I want to put it on the track bar window. So we can also keep it on the frame, but it will be on the same frame of our image. For a matter of being more clean, it's better to use different windows. So track bars, and let's copy this name in all of them this way. So we have specific window. We can change the values, and nothing changes on our mask. You can see this part, nothing is really changing right now. So nothing is really changing because we need to call it later on. Here in these values that we have here, we need to call this function each time, and we can change the value real time. So let's go inside the loop. We are inside the loop here. So how does it work? We take first frame, we convert it in HSV, then we define the ranges, we create the mask, and we show the frame. And this is made each time. So the frames, the video, it's just the sequence of these images. It depends on the camera, 25 times per second or 30 times per second or 60, depends on your webcam. In this case, it should be, in my case, 30 times per second. So let's now define these values that we can change them dynamically. First one, lower h, it's equals to cv2.get trackbar position. The trackbar name is lower h and the window name is Trackbars. And we copy this one here. Let's test this first one. I run the script and you can see that it's changing something in the mask as I'm changing this value in real time. For all the others, nothing works because I haven't defined them yet. Let's do the same for all of the 6 values. Lower s, it's equals to trackbar lower s, then lower v, I will copy them to make it faster. Lower v trackbars, and then upper h, and then upper h, upper s, and upper v. So keep in mind that we are getting the position of each trackbar. So we want to get the position of the first one. So the trackbar name and the window name must be exactly the same. First one, second one, and so on for all the rest. Now that we are getting the values, let's copy them in the right position. All the lower values here and all the upper here. And I think I did a mistake, as it should be probably lower h 0 to 2055 and the last one should be 180. I'm not sure right now, but it doesn't matter that much for the moment. And 255, 255 and 180 and 180. Everything should work correctly. Let's run the script. Let's now find the mask for the red color. No, it was probably right before. As the mask with all the ranges allowed, it should be completely white, so it was correct as it was before. So this one was 255, 255, and this 180 and 180, 255 and 180, and it should be correct. I need some light. Okay, this way. Now let's define the mask for the red. Only the red must be allowed. Okay. In general, it should be okay. It's I will define this a decent mask that we can use. To have these standard values, I'm going to copy these values on the trackbar. So lower h will be 68, lower v 154, so we don't have to change them each time. Let's keep this as standard. So we'll copy 68, 154, 68, 154, and then 180, 255, and 243, 243. We have the mask, and we're done with the first step. From this mask, let's now create the trackbar. Let's find the contours from this mask. So let's go ahead. Contours detection, let's put it this way. And we have the function in Opencv, cv2.find contours. The function returns us 3 values. The first one, we don't need it, so we put underscore. We need just the contours, which is the second one, so we define contours. And the third value, we don't need it, so we put underscores to skip it. And cv2.find contours of the mask, the mode cv2.ret3, and method cv2.chain approx simple. Now that we have the contours, we can draw them. For contour, let's call it for CNT in contours. Let's draw cv2.draw contours. We're going to draw the contours on the frame. Let's put inside of an array CNT, so inside the brackets, this value, I don't remember exactly what this stands for, to be honest. 0. We'll check it later, we can check it. And then the color of the contours, let's make it black. 0, 0, and 0. And let's run the script. And here we have the contours. Let's make it thicker, so let's change the thickness. Let's put it to 5. And let's run the script again. And we can see that we have the detection of not only the red object, also some part of me, as I don't have a really proper mask, but anyway, we will clean this part on the video. When we have not so clear mask, as we want to define only the object, we can do a couple of things. First, we can, using morphological transformation, remove some noise. We've seen in some tutorial the erosion method. So if this area, the pixel, it's like bigger than 5 per 5 pixels, for example this small dot, if it's bigger than 5 per 5, we can say okay, delete all of them. Let's do this way. Let's apply the erosion method on the mask. So mask, it will be equals to cv2.erode. We want to erode the mask, and we define the kernel. Kernel is basically a square where we define, okay, take this small square and then delete it. So kernel is equals to np.once 5 5 and then np.uint8. There is just an numpy method to create a black square. In fact, if we show it, cv2.imShow kernel it's nothing else than just this window. You can see this black small square, nothing more. And let's close this. Kernel, we erode the mask, and we're already using this mask, this erosion method, so you can see how much clearer is now the mask. So there are not all that small dots as they were before. It's a good result, so let's move on. So first we did the first two steps. First, we detected the object by the color. Second, we detected the contours. Now it's the final step to detect the shape of the contours. First thing, let's do one thing. We can see really clearly that this, for us, it looks like a square, this red part. But it's not for the code. As you can see, it's not perfect, because a square, not a rectangle, sorry, not a square, it has to be 4 sides. Here there are 4 sides, but the line is not completely straight, so it looks like if in this one line there are, for example, 10 lines, you can see 1, 2, 3, it's like more a connection of many dots. So we need to approximate these contours to make it only a square. We have the approximation method of the contours using a function of Opencv, and let's do that right now. Draw contours of CNT. We have approx, let's call it approx. It's equals to cv2.approx poly dp. We want to approximate the contour CNT. Then we define the ratio. We can change this value later, and let's see what works best for us. Let's use now 0.01 per arc cv2.arc length of CNT and closed. So the polygon are all of them closed. We're going to work with closed polygons, and true also at the end, closed polygons again. And let's draw the contours with the approximation approx, and let's see what we get now instead. You can see that now the contours are much more approximated. You can see more straight lines, and we can see the difference by printing something on the screen. For example, we print the length of the contour, so it tells us how many sides that contour serves. So print the length of CNT. So we're printing the length of the original contours without the approximation. And you can see this is the length of the contours. Let's print the length of the contours approximated approx. You can see how the numbers get much smaller as we're going to approximate the sides. We have these contours, so now really easily we define, okay, if the length of the sides is 4, so we can say, okay, that's a rectangle. If the length is 3, so if it has 3 sides, it's a triangle, and so on for all the figures. So let's do this way. We can say if the length of approx is equals to 4, so we can say it's a rectangle. Print a test it's a rectangle. Let's see. Now we don't get, probably somewhere it's detecting four of them. We can see now it's a rectangle, it's detecting this one. Let's do better this way. As it was printing the rectangle already before there was the red rectangle, because probably it was in this small part of the mask there was some really small rectangle and was detecting that. Let's improve this code. Okay, I have an idea. Let's improve this way. We can see, for example, that here there is some noise and we are detecting some contours. We don't want that. How can we remove the noise? Well, we can see that these are really small parts, so we can say, for example, if the area of the mask is smaller than some number, then we can skip it. If it's higher, so if we have big object, only in that case we can detect the object and find the contours. Let's do this way. Let's then find the area again of the contour. So area is equal to cv2 dot contour area of C and T. Area is equals to, okay. We draw the contours only if the area is bigger, let's say, than 400 pixels. If area is greater than 400, only then we draw the contours, and only then we can find the detection. So let's do this way. Let's put it inside this. Let's test it again. Now we can see that we have the mask, we have some white noise, but we don't have the contours because it's really small. Let's try with our big object. Let's see if something changed. And we can see only now the detection is a rectangle. I will say it's good work. Before going and using other objects, I have an idea. Let's put the text in real time. So we can put the text somewhere here telling us that this is a rectangle. Let's do this way. If the length is equals to 4, then we put the text cv2 dot put text on the frame. The text, let's call it rectangle. And then or I don't remember now this value of the text. Okay, yes, this is the position. So X and Y, we will check that later. The font, the size, and the color. The color, let's use again black color. So let's say 0, 0, and 0. Size 1. Okay, let's define the font before the while loop. We could define the font here, but as the font it's only one, we will use always the same. There is no point to define it each time inside the loop. It's only a waste of resources. So somewhere here after trackbars, for example, we can say font is equals to cv2.font Hershey complex. You can use whatever font you want. I will take the first one, and here we have the rectangle. Let's for the moment put position 10 and 10, and later we will find the right position. So there is nothing on the screen, there is no rectangle. I use the object, the rectangle is detected. We can see in the top left of the screen that we get written rectangle. Now we should take the position of the contours so that the text can be specifically on the rectangle. So we can do it this way. We can take from the contours X it's approx.ravel, so we are extracting the array of approx. Approx contains all the points of the polygon. So we'll take just the first point and we'll put the text on that point. Approx.ravel. First one is 0 and y it's 1. So we can just put x and y. And let's try again. We can see we have a rectangle and the text is now following the rectangle, which is exactly what we want. What if we have different objects, like a circle which doesn't get even detected? Probably the red, it's not like the red we had before. So in this case we need also to change the mask, for example, like it's now. We have different mask. The red, in this case, we can define the red based on this on the number of the sides. As we are approximating the circle, usually the circle with this approximation can have between 10 to 20 sides. So we can count, for example, 1, 2, 3, 4, 5, 6, 7, 8. So we can say, okay, if it's between 10 and 20, it's a circle. Let's add this one. If the length approx, no, let's say if 10 is less than the length of approx, and the length of approx is less than 20, then we can say cv2.putText. We copy this one, and instead of rectangle it will be a circle. Let's try this one. I need to adjust the mask to detect correctly the circle. (134), and it's detecting correctly two circles, the one in the middle and the one outside. So let's use this new mask, 66(134). Let's see if this mask works properly also with this one. And it's detecting some circle and some rectangle, so there must be some improvement to make, for sure. But anyway, 66 and 134. Now let's add for the triangle. So if the length, of approx is equals to 3, then cv2.putText triangle. Also, one more thing to fix. If and elif. Because if it finds the first, it doesn't go further. If it's a triangle, it cannot be a rectangle, so it will stop the loop and it will move on. If we put if in each one, it will try to find again. Also, if it's a triangle, it will look for the rectangle, and it's a waste of resources. It's bad practice to just leave if. And let's try now the shape detection, and let's see if it's a triangle. If it gets correctly detected, somehow it gets triangle and circle somewhere, so there is some noise to remove. We can still improve the code a little bit. Let's make some more improvement. For example, let's change the ratio of the approximation. Instead of 0.01, let's try 0.02. So we will have less sides. triangle, this works much better. Rectangle, and let's see, circle. So the mask is not working 100% fine. And also there is still some noise in the mask which is detecting, so we can change the size of the area, for example, to still improve the shape detection. And you can add, of course, more. You can add the pentagon if it has 5 sides, and you can improve, of course, much more this script. For the moment, that's all, and thanks for watching.